Mary Jo, and I work at Microsoft as a technology advisor for data and AI. My background is actually in neuroscience, so I spent a couple of years in the researching how the brain works and how it actually guides our behavior. So what I found after a couple of years studying the brain is that we know so much and we do so little with that information. So that's why at one point I wanted to make a switch, and I wanted to do some things where we actually use all the information we gather in research and we gather in academia and implement it into society to actually make our society better. But today I'm here to talk about artificial intelligence. And I wouldn't work for Microsoft if I wouldn't start off with a Bill Gates quote. So a couple of decades ago, when Bill Gates started with his mission of getting a computer on every desk in every home, he actually also said that his aim was to develop computers that one day could see, hear, talk, and understand human beings. And if you think about it, that's actually exactly what we're trying to do with AI. With artificial intelligence, we're trying to create machines that show capabilities that are typically associated with humans. So when we think of what is actually typical human, we think of a couple of pillars if we look at it from Microsoft's point of view. First of all, we have reasoning. So if you get data in, what can you do with it? How can you base conclusions out of all the data that you interpret? Secondly, we have understanding. So that's something that you see in a lot of projects right now. So how can we understand what is happening? Not only if we have this Excel table filled with binary data, but also if we have pictures, or if we have audio, if we have text, what can we do with that kind of information? So it's exactly like the human intelligence. We try to perceive the world around us, and now we're also teaching our computers to perceive their world around them. And thirdly, if we have these machines, these computers that can understand what is happening around them, reason from it, and gain conclusions, how can we make sure that this actually comes back to us? So how can we make sure that these machines can interact with us in a natural way for humans? Because one of the examples that computers don't have to be human is actually that there was a project where you would have two bots talking to each other. And at one point, they would be talking so efficiently to each other without so much hoo-ha around it, that it wasn't even language that human beings could understand. So that is why it's really important for us to build these machines that can interact with us on a natural way. But then there's also the question of what actually makes something intelligent. And if you think about it, AI is not something very new. So it actually has been around for decades. If you think about this concept of that you try and create a machine that encompasses human intelligence, then you could also say that a calculator is is AI, because it can do something that normally a thing or a machine wouldn't be able to do unless we program it to have the same intelligence as us. But of course, right now we don't think AI is simple mathematics. But then a couple of years ago, we of course had this world champion in chess that was beaten by AI. But then, if you think about that, it's just a simple game where you have a lot of rules and a lot of tactics, and every time that the opponent plays something, the computer just has to think of what is the best possible reaction to this. It's very rule-based, it's very statistical. But in that time, that was the best that AI could do. Right now, we don't even consider it AI, it's just plain statistics that you learn in high school maybe. Maybe not in high school. But now, we actually, if we talk about AI, if you see AI in the news every day, we're talking about self-driving cars. So if you think about AI, it's not necessarily what it means. So it can have a lot of different definitions for different companies and for different organizations. But what you can see, what the trend is, that actually AI is more about what it can do in the future. So what can it mean in the future? It's very much looking forward and not so much looking backwards. Just to have a foundation before I talk about the different examples that you can use AI in enterprise, I want to first make sure that everyone understands how AI works. So a lot of different terms often come by when you talk about data or you talk about AI, and one of them is, of course, data science. But when I would talk about data science, then I would just say there was a lot of data points, and you're trying to process those data points to find a sort of pattern in it. And if you talk about AI, you should more see it as the bomb-sniffing dog. So think about a dog that has a very specific task and is trained to do that task without you giving certain rules for it. And that is actually where we are with AI today. It's very narrow, what we call. So you have narrow and general. And general would be that it can do exactly what a human being can do. And with specific or narrow, you talk more about the specific task that you train it to do. So with the bomb-sniffing dog, it can do one thing really, really well. And you train it to do that with all the data you have. But for the rest, it's probably kind of stupid in human eyes. So how do we train a dog like that? And for that, we actually have looked at how children learn. So if you think about how children, for example, learn a language, then it's not that you give them all the rules of a language. It's not that you give them all, like, this is the grammar, these are all the rules, and this is how it works. And then naturally, the kid starts talking. No. It starts from a young age, it receives examples, it repeats a couple of examples, it makes mistakes, and every time that it makes a mistake and someone is around, it gets feedback saying, no, that's bad, and then it improves every now and then. But if you look at a kid, it takes years to learn. And after those years of learning, it still continues learning. But then, in the end, you'll have a child that speaks the language. And that is exactly how machines learn. So you have all this input that a machine will try to process. It will start looking at the different patterns in it. And then afterwards, it can, gain certain conclusions from it, just like a kid would do with language. It's not that the child at one point would realize, oh, this is a grammar rule and this is how exactly it is. It kind of tries to find the logic behind it, and it's very flexible in that. So if we're taking back to artificial intelligence, then you could see artificial intelligence in a whole as just trying to have these machines encompass human intelligence in any way. But as I said before, then you can also include statistics or very simple regulatory expressions. A part of AI then is what we call machine learning. So those are those self-learning algorithms, like the dog, like the kid. You just give information, and then you can either try to have it know what it should, what its target should be. So for a dog, it knows it should detect a bomb, and that is the goal. And then it uses all the information that is within reach to learn when it's a bomb or not. But you can also have unsupervised machine learning, where you'll just give all the data and it starts making sense of everything. So that would maybe be more like language. You just get all the input and you try to make sense of it in a way, but it's not that your goal is to have all the grammar rules out of your head after 10 years, for example. And because we look a lot at how people think and how kids learn, that's why at one point we also looked at the brain. And in the brain, you see that it works with neural networks. So you have a network of different nodes that make different connections. And that is where deep learning actually comes in. So here we tried to mimic the human brain. And you can see that the difference between the two is also that with machine learning, you often see a lot of structured data. So you see that, for example, you have huge Excel files that have all the numbers on a certain situation. So one example would be that you're trying to predict whether someone is going to get car insurance or not. Then you'll have their age, you'll have their bank information, you'll have where they live, those kind of things. And they're all just very structured information. You can all paste it in a table. And then you can just have machine learning model predict whether they will buy a car and whether they will get a car insurance at a certain time. But with unstructured data, and then we're talking about text, we're talking about pictures, we're talking about audio, it's not very logical how that works. And there we actually looked at the brain, of how the brain looks at an image. And you see that it actually processes a lot of different types of information in different layers. So for example, if you have a picture, then you have so many things in a picture that you want to include in your processing. So it's not only the color, it's also the orientation, it's also the size of something. And that needs to be processed in so many different layers, actually in parallel, that you need a whole network to do that. But most of these algorithms that make up one of these things actually aren't that new. Still, AI has been a buzzword for the last 5 years. And why is that now? So we see 3 trends actually that make AI be something of the now. And first of all, we have a lot of data. So that's also the reason why all of a sudden in every news article we're talking about data or big data or anything like that. Because we have we measure a lot of information, we save a lot of information, and we have access to a lot of information. Secondly, we have a lot of powerful algorithms. And this is something that is not so new, because the mathematics has actually been around for a while. Yes, with deep learning, there have been some breakthroughs over the last couple of years, but overall, this is also not so new. But the third trend that really brings everything together is actually the big compute. And that just means the cloud. So because of the cloud, we have the ability to really have the computing power that we need. So for me in science, I can remember that whenever I would try to analyze any signals from the brain or fMRI images, it could take me a week or 2 weeks to just run one simple script. And with the cloud, you can very easily just ask for what you need, and you can run a script like that in only an hour, because you're not dependent on the hardware you have in-house. You can just ask for what you want. So that is why, with the three trends together, right now AI is really booming. But then before I really dive into the examples, just as you have bad kids, you also have bad AI. And you may be familiar with one very famous example that's actually from Microsoft. We had a bot on Twitter, and it was called Tide, and it became racy very quickly. So here you actually see what happened. And the thing how they built it was actually that it started learning from the input that people would give it. So people would tweet to our bot, and then from the input, it would also learn how to speak to everyone. But this is exactly how a kid works. If you teach it only swear words, then all it's going to respond with, all it's going to talk with is swear words. So you would get, things like this. So what went wrong? The model is really defined by the input. So you can have a great model, you can have a super smart bot, but if you give it the wrong data, then it's not going to be very efficient. And that's the same for many other projects. And there is often very tricky, because the data that we have can also be unconsciously biased by us. So another famous example is also in the US, where they try to predict who would be a criminal, or who would have committed a certain criminal act. And there it turned out that if you're African American, you're almost guaranteed to actually commit a criminal act. And then you can think about, okay, is that actually true? Is the AI only giving us, a truth that actually is there, but we never dare to say? Or is the data, because the data was, of course, gathered from people that were in prison right now. And you can also think about, well, maybe the police officers are actually also really racist, and everyone has a stereotype, and black people have actually been arrested more often, or have a higher chance of being arrested, even though they maybe commit the same crime. So there you really have to think about, what kind of data am I using, and is it actually really representative of what I'm trying to predict, or what I'm trying to do? So here you see how people at one point actually realized how Tide works, where if you just asked it to repeat something, it would repeat it, and that's how it went wrong. And what we learned from this is that actually right now, the way AI is built right now, humans are still necessary. So even though AI can, what they often say, replace a lot of the things, it can now only help us, and we are still needed at the end to make sure that everything is right, to make sure that the data is right, and that the model connects with the data, and that the interpretation of the model is also being done in a logical way. Because here is another example, going back to the car insurance. If you have your table and you just throw in all the data you have, for example, your ID number, where it could just be, when you join the bank, you have an ID number, and it will include that data in your model, then it might happen that that is all of a sudden predictive, even though that has nothing to do with it. So those kind of things is something right now that only humans can take out. Only humans can realize what is logical for us in society. So our view on AI is that you can do it in a couple of ways. And of course you can create your own machine learning model, your own deep learning model. You can have your own use case and try to find a solution to it. But what we really try to do is encourage you to work with what's already out there. So we have a couple of things that are very typical for a lot of companies, and we actually make these models already, and you can just use them without having to train it, without having to build an algorithm. And we call these services the cognitive services because they are related to what AI can do. And we divide them in a couple of categories that are kind of related also to the human senses, if you look at, for example, vision and speech. And an example for vision would be that you can classify images. So if you have images of dogs or cats, then you can give at one point an image and it will recognize if you have a dog or a cat. With speech, you can think about speech to text. So if I'm talking right now and afterwards you want to look up what I said, then you can just, by having an AI model you can have everything I said very simply being transcribed without having a human type it out. If you think about language, it's about the language understanding. So that's, I think, also what you'll talk about later on with your chatbots. So how can we understand what someone is saying, but also how can we make the machines produce something that we can understand? And so you have a couple of things that are very typical for a lot of companies to be used, and that we try to make very easy to use. So an example is also from McDonald's. I don't know if everyone has been in the McDrive, but sometimes it can be really annoying, the sound quality of the McDrive. And imagine if you're working on the other end and you have to take in all the orders, it can be very disturbing and you hear all the sounds all the time. So what they actually did is that they used our speech to text and they only specialized it a little bit more for their specific situation because their surrounding sounds are very typical. And then they had this AI model that they almost did not have to do anything for. They only had to give a certain amount of training data. And they had a model that could just transcribe to them what the order was from a person coming in. And that already simplifies someone's job, and even maybe then you don't need someone who has to take the order, and you can focus more on customer satisfaction at the desk or when they're actually seeing you face to face. So those are the kind of things that you could do with one of these cognitive services. I often get the question, how reliable are they actually? And funnily enough, we are actually pretty far with a lot of them. Every year, for some of these things, there's a competition, international competition, where all the tech companies take part in. And there are standardized tests where we then try to be better than humans. So one example is actually the speech recognition, where you have the customer service calls, and you try to, or we, as tech companies, we try to then transcribe what is being said in customer service calls. And right now, or since 2017 actually, we are better than a human would be. And funny thing here is also that even though we still make mistakes, we make less mistakes, and the mistakes that are being made are, for us, really stupid, so we take them out immediately. So if you want to make sure that you're a retail company, you have a customer support desk, and you want to know what is being said, what people talk about, you can have a student, a very cheap person, just transcribe all the conversations. Or you can have AI do it and then have someone check it. But then instead of hours, it can take 15 minutes per call. So that's one of those examples where AI can help you to be more efficient in your job. Let's see. And here is a nice video of another thing we did with our services. Let's see if it works.
I'm Sakib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces. 40-year-old man with a beard looking surprised. 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate. And I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So what's really cool about this is that for everyone who has an iPhone, you can actually download this app for free. It's called Seeing AI, and you can then, what he actually explains, so you can take a picture of someone and describes the person to you, or you can take a picture of text and it will say what's in the text. So those kind of things are nice to see what AI can actually do now very easily. Another example is this. This is called Video Indexer. And here what you do is that you just upload a video, and there are a couple of services that are attached to this. One of them, for example, is that it transcribes the whole text, as you see here. And as I said before, with customer service, it can be interesting what kind of topics have been talked about. But also, if you want to look through the transcript and see whenever someone said something. So here, for example, it'd be, I want to know when he said something about AI. Or if you're a company that has a certain show on TV, then you want to know when exactly they said something, or when on TV it was said, or if you have a commercial, you want to see exactly where it was said. And then you can just look for it, and it'll go exactly to the moment in time where it said it, and the video will start at the point where they talk about AI. And next to that, you also see another service that's attached to it, so that's the Face API. It's the same where you saw on the previous app that it can detect the face and it can talk about the face, saying, for example, what your gender is or what your age is. And you see here that there's also the ability to identify people. And this is also in combination with Bing, which we still have, where you can see who's, certain famous people, as this is our CEO actually, Satya Nadella. And then it will immediately recognize that this person is in the video, and it can show you exactly where in the video he shows up. So those kind of things can be really interesting, for example, a media company, or if you have a lot of video material. Let's do a short demo. Yep. And another way that we actually show these kind of things is our very easy demos. Let me duplicate. So here we have this, and we have a couple of things that we can do. So imagine you have a Face API in a car, and you want to make sure that whenever someone's driving, you actually know that they're watching the road. So here you can see that, first of all, it identifies me as a driver, and it already knows me. I've been training my demo that it can recognize me. So for example, if you want to make sure that no one else can drive your car, or another example is that Uber is using this. So, short intermezzo, Uber actually does this for the verification of the drivers, and that's because of security reasons, but that's also because you want to make sure, as someone who's in the car, that your driver is actually the one that has been approved by Uber. And next to that, you also, as a driver, want to make sure that no one else can just steal your account. So I think, I want to say South Africa, for example, there's a stop on Uber drivers because there are so many people that actually want to do it and gain money with it. But there's also a huge black market in accounts. And this way you can secure those accounts and make sure that the only people that actually got the accounts are those people that are driving, and not just anyone, so that you know that everyone has been verified. So with them, every time that they are starting their shift, they have to take a selfie. And with the selfie, it's actually verified whether they are the person from that account, and they are verified to be the identity that has been linked to the account. So that's one use case you can use it for. And another, of course, would be for safety in general, whenever you want to make sure that people are not distracted. So if I would now pick my phone up, it'll work. No. Then normally you would see with the distractions that something would happen. And as you see also, it looks at if your eyes are open or not. So if you're falling asleep, it can give an alert. Or if you're looking the other way all the time, it can also give you an alert. So those kind of things can be really interesting. And another cool thing is also that talking about text, you have the ability to not only get topics from text, but also the sentiment. So how are people feeling if they're talking about something? So if I type in Amsterdam, for example, I want to know the reaction. You can here see that it's green if it's a positive sentiment, so if people are talking about it in a positive way. It's yellowish if there's a neutral sentiment, and it's red whenever they're very negative about it. So if I talk about artificial intelligence, you already see more variation. You see that 87% is still positive about it in the news, and 13% is slightly negative about it. So those are also things that you could do with AI. Let's see. I'm going to skip this. Here an example would be that you're working on a construction site. Imagine that there is an apartment building that's 10 floors high, and you're looking for a very specific drill. Then if you have cameras all over the construction site, then you can just ask through an app, where is that specific drill? It can locate it, and then it can make sure that an authorized person, someone who's authorized to take up that drill because it might be very dangerous equipment, will actually take it to you because your location is also pinpointed by the app. So again, those are things where we can use AI for. And I think the essence is that instead of that we learn how to use technology, we try to make sure that technology actually learns us. So what do we mean by that is that we actually want technology to act more or to be more natural for us. So a very simple example is that normally you would text someone whenever you want to send them a message, but if you think about it, you have to learn how you're sending a text. That's not something very natural to us. It would be more natural if we just speak to them, and that's how voice messages, for example, are a more natural way of interacting with technology. And that's where we want to go. So we don't want to make us go through all this trouble to have the advantage of technology. We want to make sure that it actually helps us and does the way that we can profit from it without having to learn how specific equipment works, for example. So I've given you a couple of use cases, and I also want to give you some best practices. Oh, see that one point missing. First of all, I would say it's really important to clearly define your business opportunity or your problem. So what I often see is that people, they hear AI and they think, that's cool, I want to do something with it. But it's very important that you clearly find what it can actually do for you, and that you also set success criteria to it. Because then you know if you're trying it out, when to stop and when to actually continue with your project. Another thing that we often also interestingly see is that organizations or businesses that want to work with AI don't have data. So they want to do all these things, but they're not saving or storing the data that could be useful to them. So that's something that is also really important. And even if you have the data, then access to that data might also be really important to make sure that you have right. Then thirdly, you have to understand your data. Often people come up with all these ideas to do something with AI when all they want to do is actually get simple insights, simple visuals on their data. They just want to see what's going on. Then you don't need a very specific model to be trained. You just want the results of what has been happening all these weeks. So with this understanding of data, you explore your insights, and then you have to realize if you still need something with AI. And here again, it's really about asking the right question. So what exactly are you going to do, and how is this going to help you? And how are you going to make sure that you decide on whether to proceed or not? And lastly, what I also want to really, really state is that you can always use available tools, or try to use available tools. You don't always have to reinvent the wheel. So what I talked about before, for example, with the cognitive services, those are things that you can use without having to write whole algorithms, without spending months and without hiring data scientists or have a PhD in computer science to start. And that's something that makes AI a lot less scary and a lot less, more accessible. And I think that's something that organizations should really look at. So I just want to close off with saying, we always talk about the future is AI, but the future is actually here. And that if you want to know more about AI, definitely download the Seeing AI app if you have an iPhone, because it's really cool. And if you want to start with some projects on a really easy scale, then you can always go to gallery.azure.ai, and there we have some template solutions or solution templates that are very easy to start out with. Are there any questions?
Yeah. What would you say was the main kind of drawback of using a service as opposed to like a native implementation?
The basic answer is always it depends on your use case. But the major drawback would be when it's critical for your core business. So a very good example is for a hospital, if you want to predict, for example, in MRI images whenever there's a tumor or not, then you can use a service to do object detection. But if it's a very critical thing where you need to be right, and it's very specific for your case, and you need a lot of domain knowledge to get this right, then I would not recommend a service like that, but to actually create your own model. Yeah. Any other questions? Yeah.
Yeah, you said something about speech recognition is now better than human, and I was wondering, usually that means American English without the accents. So is that the case here as well, or does it detect any kind of language and any kind of accents in languages?
Yeah, this is a standardized test. It's indeed with English, but then there are still some deviation, of course, with accents. But what you say is definitely one of the problems with AI. It's not only that there's the bias in AI that's a problem, so that's not only for the example that I said with the African American criminals, but it's also with language. So the training data often consists of native speakers, and if you have accents, then that's often a problem. So that's something that we are all working on, a lot of big tech companies, but it's definitely something you also need to take into consideration. Yeah.
I more or less had the same question on the translation parity with humanity.
Yeah.
My partner is a professional translator, and I would like to go home and tell her that she can stop working. Do you know something more about the background of that story there? Is this comparing verbal translations or written translations, or do you know anything about that?
Don't know the exact story also, but I do know that this case was English and Mandarin. And I think it wasn't written text. Okay. But if we use, because if we use speech, then of course you have to first convert it to text and then it's a translating, but then you have an extra error rate because you have to convert to text. But yeah, here again, I mean, with those kind of cases, it's very easy to say to a translator that, oh, you're not necessary anymore because we have a model that does it better. But I would say, no, you can do so much more all of a sudden, because it might still have an error rate and it might still make mistakes. But now you can do your work so much faster. And there's still a lot of things in translations and language that is very hard for us, like sarcasm, for example, is a major problem. And different jokes can be very different in different cultures. So that's the human component that we still need. So again, I would say, yes, AI is pretty far, but we still need humans.
Yeah, I still believe it will happen sooner or later, but I'll look at how far exactly.
Yeah?
Yeah, there's a similar question also about the facial recognition. Also again towards like how well it is, because can it determine the difference between showing a picture in front of it versus an actual face? Is it that good? Because otherwise you just go sit in the car, put a face in front of the selfie, and voila, you've created the system. So I was kind of curious how far you are with that.
Yeah, with the facial recognition, you definitely need a 3D face. And here, a funny anecdote is also that, I don't know if you had heard it about Apple, that they had face recognition and then it was hacked within a day or something. What they actually did is that they rebuilt 3D models of someone's face, or someone's head actually, and with that they could access their phone.
So yes, if you have an exact representation of someone's face, you can do it. But there you notice that it's definitely important to have the 3D image of someone and not just a picture for it to work. Yeah. Any other questions? Yeah.
Right, so if we go back to the Bing Analytics search field and put the AI singularity, probably it will show a lot of red, a little bit of yellow, less green. My question would be, without analyzing it, what are the discussions in Microsoft around the topic on AI singularity when artificial intelligence takes over the world? Will humans still be alive, or basically speak on behalf of Microsoft, or maybe your own opinion?
Yeah, so the view we have on AI, first of all, is that we call it democratizing it, so we want to make sure that everyone is able to. So that's why a lot of these things are, for you to be able to use it without working for an organization, having a lot to invest in. And that's one of the things. I think a major topic is also the future of work. So what are we going to do if AI takes over a lot of things? Because the state it is in right now, then it's more that it can help you. It can, what we call amplify human ingenuity, to give it a fancy term. So it cannot replace you completely yet, like I said with the translations, but it can really make sure that you can be more efficient in your work and you can focus on what's important. That's how we look at it with the state now. But definitely, if you look at the future, then AI can take over a lot of, especially manual labor. And there, what we see as the most important thing is that we make sure that people actually have the skills of the work of the future. So we're investing a lot in different boot camps, and there was actually a huge boot camp the last couple of months, and that was specific for women actually, to train them, to retrain them in IT or in computer science, because we really think that with the skills that we have now in society, we're not prepared for when AI takes over for a lot of things. So that's where I think the stance is. Yeah? Okay.
Okay, all right.
Well, thank you.
Thank you very much.